Hey everybody, we are back with .NET Conf Focus on Blazor Day. I have Eagle Hansen, who's all the way from Iceland, talking to us about testing components in Blazor. What do you got in store for us today, Eagle?
Yes, well, exactly that. I'm going to talk about testing Blazor components. So I'm going to expand on what Steve said earlier, hopefully, and give some insights as well, hopefully.
Perfect. Take it away.
Yes, let me go ahead and share my screen. And this looks like the right button. And presentation, like this. And I think that's it, right? Okay. So, like you said, Xavier, my name is Eagle Hansen, and I'm a managing architect in Netcompany. And you can find me on Twitter at Eagle Hansen. So I'm calling in from Iceland, and you might have a little bit of snow up there, but I have quite a lot, so it's even started snowing in my slides, as you can see. Hopefully that'll be okay for everybody. No jokes aside. This session is about testing Blazor components, so let's get started. First, I'm going to talk about the basics of testing Blazor components. Secondly, I'm going to show you different styles we can use when testing our components. Then I will show you how to interact with the component under test. And finally, we will look at different verification strategies available to us. This session will not cover the basics of Blazor nor how to build custom components in Blazor. So if you are new to Blazor, you might want to watch some of the other sessions first. I also won't be talking about unit test in general or test development. So with that out of the way, this session is based on my testing library for Blazor components, which is available on NuGet and GitHub. The primary goal of the library is to make it easy to build stable and maintainable tests in Blazor components for Blazor components. The library itself builds on top of other great libraries and frameworks. These include XUnit, AngleSharp, my own AngleSharp diffing library, and of course Blazor. It also incorporates Steve Sanderson's testing prototype that he published last fall. So big thanks to Steve for taking the time to create that prototype. It helped me add a bunch of features I was missing in the early versions of the library. Also thanks to all the community members who have been providing input since the beginning and continue to do so. All the samples I'll show today, as well as documentation, plus many more samples, is available in the GitHub repository at this URL on screen right now. Okay, so with that out of the way, let's get started with the first topic. Let's start by quickly talking about what it means to test a Blazor component. So you will need a way to provide input in a Blazor-centric way to the component. That means, providing input to the component and injecting any services it depends on. You also need a way to trigger or invoke the component's lifecycle methods and render tree logic. And last but not least, you need a way to verify the output of the component, mostly expecting the markup generated. So this might not be a surprise, and you might be thinking, so yes, Eagle, of course, that makes a lot of sense, but why do I need a testing library for that? You could have asked, why can't I just new up my component under test and use the regular frameworks I'm used to, like XUnit or MSTest or NUnit, to test that with? So the main problem with that is that a component doesn't know how to render output. And that's a clear separation of concerns in Blazor, and components need a renderer to produce markup. The Blazor framework also ensures that the component lifecycle methods and re-renders happens at the expected moments. So my library helps with that, and through a couple of abstractions we'll look at now. So the first abstraction is the test context. It allows us to register any service we want to pass to the component under test, and it allows us to render a component or a fragment. So if we want to render a component, we first register any service it might need, for example, the JS runtime, and then we ask the test context to render it with any parameters we want to pass to it. The result of this is a rendered component or a rendered fragment. A rendered component is a rendered fragment, meaning that all the things a rendered fragment can do, so can the rendered component. So the rendered fragment gives us access to the rendered markup as a raw string or as DOM nodes. The DOM nodes are provided by the AngleSharp library, which is a complete implementation of HTML5 DOM API. So that means you have access to all the APIs for working with DOM nodes that you know from the browser and JavaScript. There are also two helper methods for querying the DOM nodes, find and find all, which both takes a CSS selector as input and return DOM elements. Through the DOM elements, we get a convenient way to trigger any event handlers that are bound to the DOM elements. For example, the onClick event. Doing so will trigger the C# method that is bound to the event, and a re-render happens afterwards, as you would expect. The render component gives us access to the component instance, from where we can expect public properties and invoke public methods. You can also render the component again and with new parameters if you wish to do so. So there are a few other things we can do with these three abstractions, but these are the basics. With that out of the way, let's look at the different testing styles supported by the library. So the primary difference between the testing styles is how we create the component under test and any HTML fragments we might need in our tests. The first style we'll look at is the C#-based testing style. It's basically the same thing as Steve showed earlier. My library does it a little bit different, but you should basically see the same concepts and patterns here. So let's look at a few pros and cons with this style. On the plus side, in this style, everything is written in C#. It is, in other words, just a regular XUnit test you will be creating, like the one you see here on the slide. So everything should feel familiar to you if you do that. You are required to inherit from the component test fixture type, which is a text context, like we talked about in the previous section. It also has a bunch of helper methods that will make it easier to provide input to the component under test. So on the minus side, even with the helpers, if you have a component that takes a lot of parameters, the code used to render the component can become quite complex and unwieldy, especially if you also have to pass a child component, which also takes a bunch of parameters as input. And writing HTML markup in strings in C# is also not ideal, although string interpolation does make it a bit easier. So an alternative to this is what I call razor-based testing. The upside with this style is that all your component and markup declarations happens inside the fixture component in Blazor syntax. So that is much more natural way to declare your components and pass parameters to them. In the Razor test files, you are required to inherit from the test component base type. It is a text context and has helper methods for getting the component under test and any fragment we define in the fixture. When the test runs, the setup method and test methods passed to the fixture are called, and we can use C# for interacting with the component under test and verifying its output inside the test method. The test runner in Visual Studio and the console will run these tests just like your normal unit test. It is, however, not able to distinguish individual tests within the same Razor file yet. That's something I have a good idea of how to fix, but it's not a priority right now. So this is still experimental, and since this is a new way of working with test, I consider this experimental and reserve sort of the right to change the syntax around a bit to get the best possible developer experience. And if you have any input or feedback on how this should work and could work better, please come and share that. The third style available to us is what I call snapshot testing. Like with the Razor-based tests, snapshots tests are written in Razor files, and you are also required to inherit from the test component-based type in this style. Those of you familiar with the Jest JavaScript testing framework will probably see some similarities to this. A snapshot test basically consists of two parts, a test input and an expected output. When the test runs, it'll automatically compare the rendered results of both and using a semantic HTML comparison. This style is also experimental, so a few key features are missing to support proper snapshot testing. For example, automatic expected output generation, and the same limitation that we had with the test runner in Razor-based testing is also an issue here. So with that out of the way, let's look at a few examples. Right now, I'm going to start by focusing on C# and Razor-based tests, and we'll get back to snapshot tests later. Our component on the test for the examples will be the Bootstrap alert component, like the one we see here on the slide. It has a bunch of features that will allow us to see various parts of the testing library in action. It allows us to pass header text and any child content into it as we wish. It allows us to dismiss it by clicking on the X at the top right corner, or through the dismiss method on an instance of the alert component. It uses CSS animation to fade the alert away when it's dismissed, and after the dismiss animation is done, all the markup will be removed from the DOM. We can pass in a text localizer to it through a cascading value that it can use to localize the header text. It'll also trigger event callbacks before and after it is dismissed. And finally, it uses JavaScript interrupt to read how long the dismiss CSS animation takes to run in the browser, so that the markup is not removed before the animation is done. And just to show you a brief demo of what we are going to test, we have it down here in my browser, and it's sort of the standard testing sample app we have. And you can see if I click the button up here, you will see down here in the alert status section that will first show that it's dismissing, and after a little while it'll show that it's dismissed, and then it'll be removed from the DOM. So you'll see the sort of hello.NET conf will jump up. So let's go, and here it comes. If we quickly go back, we can also see we can click the dismiss alert button, which is an external thing to the alert component, and it'll do the same thing again. Okay, so let's try and test this. Now, in the interest of time and not having to watch me type in Visual Studio, we'll switch to my very special version of Visual Studio. We can call it the Power Visual Point Studio, where typos and compiler errors are a thing of the past. So we'll start with a Razor-based test where we typically pass in all the parameters and input that we can to the alert component using the Razor syntax. So this should seem familiar to you if you're used to Blazor. So first, in our Razor file, we start by inheriting from test component base. Then at the top level, we have our fixture component, in which we declare the component under test component. The child content of the component under test component is what will be rendered and passed to the test method. Inside that, we declare a cascading value and pass in the localizer, just as we do in regular Razor pages or components. Then we declare our alert component with its parameters, including a component, the paragraph component, passed into it as its child content. Tests and setup methods are declared below, so let's go and have a look at those. In the setup method, we just register the mock.js runtime that comes with the library, since the alert component has a dependency on the i.js runtime and cannot be rendered without it. We also add our Yoda language alert heading translation to the localizer. So now we're ready to get our component on the test. In the test method, this can be done in two ways depending on what you need. If you only need the functionality of the render fragment abstraction, you call the non-generic version of get component under test. If you need the full functionality of the rendered component abstraction, you can call the generic version of get component under test and pass in alert as the generic argument. We will look at how to work with the component under test, or CUT for short, in a later example. So now it's time to look at this example in a C#-based test. In our C#-based test, we start by creating a class that inherits from the component test fixture type, and then we create our first test. Inside the test, we start by registering the mock.js runtime in the service collection in the test context, like we did in the Razor test. This could be moved to a test classes constructor if we have more tests that inside the test class that needs this. Then we declare a few variables to hold the content we want to pass to our alert component and initialize our localizer. Now we are ready to render our components. And this is done by the generic render component method, where the generic argument is the component we want to render. In this case, it's the alert component. The render component method also takes 0 or more parameters as input, which it will pass to the component during the first render. So for regular components, we can simply pass a tuple with a name and a value. So in this case, we are passing the value of the alert's header parameter, as well as the header, the value we want to set to it. This can be made more refactor friendly by using the name of operator to capture the parameter's name from the component, like so. So this is how I recommend doing it, because even if it's a bit more noisy, because if you refactor the name of the header parameters in the alert component, then you don't have to go and fix your test afterwards. Okay. So the next thing we want to pass to our alert component is the localizer. The alert component receives that through an unnamed cascading value. So to help us do this, we have the cascading value method, which just takes the cascading value as input. If you need to pass in a name cascading value, the cascading value method has an overload that takes a name as well as the cascading value itself as input. But we don't need this in this case. The event callbacks are passed using the event callback helper method. It takes the name of the callback parameter as the first argument and a func or action delegate as a second argument, where the input matches the expected generic type of the event callback parameter. So note that we are also using the name of trick here to make the parameter name a refactor safe. Last, we need to pass in the child content of the alert component. We can do this with the help of the child content method. In this variant, we are using the generic child content method to pass in a paragraph component to the alert component, as we did in the Razor-based test. The generic child content method takes 0 or more parameters that should be passed to the paragraph component when it is rendered. So it is a lot like the render component method in that regard. If we just wanted to pass in some markup or a string, there is another child content method that takes a string as input, but to keep things equal with the Razor test, we don't use that in this case. And just to show you, this is the entire test so far. We will get back to the act and assert steps in a bit. The C#-based tests can be more compact, but when a component takes so many parameters, then it becomes a little hard to work with. And I haven't even shown an example of passing in a Razor template, where we unfortunately have to step into sort of a render tree builder territory, at least for now. I'm hoping to build maybe some helper methods around that as well. A good thing is that you do not have to pick a star and only use that. All 3 stars can be used within the same test project, so picking the one best suited for the test at hand is definitely possible. Okay, so now let's talk about how we can interact with our component under test once we have it. We can work with and get the rendered markup in a few ways. The get nodes method returns the rendered markup as a node list. The get markup method returns the rendered markup as a raw string. And the find and find all methods can be used to query the DOM nodes. All event bindings available in Razor can be triggered on the DOM elements they are bound to. This example triggers the onClick event handler on a button component or button element. We can also render the component under test again, causing it to go through the component lifecycle. This can be with or without new parameters. And last but not least, we can expect the component on test instance through the instance property on the component under test. So this is the basics we need to know to work with our component under test. Okay, so with that out of the way, let's talk about some verification strategies available to us. So picking the right verification strategy is important. It will increase the likelihood that the test will not break unnecessarily, and be able to catch regressions if they happen at a later time. So we do not want our tests to break unexpectedly. We want happy devs. Or as coding Yoda puts it, unexpectedly breaking tests leads to delays, delays leads to angry managers, and angry managers, well, that leads to tests being deleted or commented out. And we do not want that. So I'm not going to talk about general unit testing verification strategy here, but instead focus on verification of rendered markup. In this library, the two most common approaches is targeted inspection of markup and performing semantic comparison of it. So let's take a look at each in turn. Okay, so by targeted markup verification, I mean the kind where you find and select nodes or elements in the rendered markup. This strategy can lead to quite stable tests, as they only break when the specifically target nodes or elements change. The downside of this is that changes to other parts of the render markup will not be detected. So you can obviously compensate for that by having more tests. Another issue to be aware of is that changing indentation or adding line breaks in your Blazor files can cause text nodes to change, even if it is an insignificant change from an HTML point of view. So your test will have to deal with insignificant white space to remain stable. So in this last example here, we are using the trim method to do just that. The alternative approach is the semantic markup comparison, where two pieces of a markup is compared and remain equal if they are semantically the same from an HTML point of view. This is supported through a library I built on top of AngleSharp called AngleSharp diffing. The advantage of using this to compare markup is that your tests will be much more stable with regards to insignificant changes. For example, so let's consider these two HTML fragments. We can change a bunch of things in either of them, and they would still be the same when rendered in the browser. We could, for example, reorder attributes on an element. We could remove or add insignificant white space, or we could change the order of CSS classes in the class attribute. So these are just some of the examples of insignificant changes we can make to our rendered markup that doesn't break our test when using the diffing library. We also get the possibility of doing more complete tests. We can verify all the rendered markup and thus be sure that only the DOM nodes we expect to have changed are changed. In the example here on the right, we are using the markup matches method. It allows us to verify the rendered markup from our cut matches the expected markup string. So you might be thinking, yeah, Eagle, but that's neat, but I don't want to specify the complete markup each time I have to verify some rendered markup. And you would be right, that would indeed not scale very well, and there would be a lot of, and if there are any breaking changes, you would probably have to update the expected markup in a lot of places. There are good ways around this. One example that works today and quite well is this here on the right. So here we ask our already rendered cut to re-render with new parameters. Then we call the get changes since first render method, which produces a list of differences between the markup produced during the first render and the second, that we can then verify only contains one change, and that change should be an addition in this case. So this verification style, the semantic comparison style, can also be too tentative if you're not careful, and cause tests to break when they shouldn't. Usually because we are verifying more broadly than the test actually intended to do. So there are a few ways to get around that. One way is to customize the diffing method through special diff modifiers in the expected markup. Expected markup can also sometimes be referred to as control markup. There are many ways to modify the diffing logic built into the library, the diffing library. One of the simpler ones are shown here, where the diff ignore attribute tells the differ to ignore the h1 element, its attributes, and any child nodes it might have. The differ is also configured to automatically ignore the special attributes that the Blazor renderer adds to the markup. So, for example, the attributes it adds to track referenced elements or the event handler bindings. The pair to method shown here in the last example, so that's another way to do the semantic comparison, and it'll just compare the rendered markup with some control markup and give you a list of differences that you can assert against, like we do here. Okay, so Let me just get a cup of my tea here. So with that, let's look at our examples again and try to interact with the component under test and verify against it. So we are back in our Razor-based test from before. In this test, we just want to verify the alert component renders correctly if all parameters are passed to it. To make the comparison easier, we add a fragment component to the fixture where we specify the expected output from the alert component. So let's go to our test method below and see how we can use this. So down here, the test method, in the assert step, we use the get fragment method to get and render the fragment we defined in the fixture above. Then we can use the markup matches semantic comparison method to compare the output from the cut with the expected markup. And that's all that's needed. Now we have verified that everything is okay, and that's it. So let's look at the C# version, how that looks in the C# version. So this is our C# version from before. I've removed some of the parameters we didn't need, but otherwise it's the same. Let's scroll down to the search step and add some code here. So here we basically do the same as we did in the Razor test. The only difference is that we have to write the expected markup as a C# string with all the fun that comes with that, like escaping the attributes, for example. And then we just call the markup matches method again, and we are done. So that's quite simple using the semantic comparison. So we haven't looked at any snapshot test examples yet. So let's try to write the same test in that. As with Razor-based test, we inherit from the test component-based type in our Razor file. Then we add the snapshot component with an inline setup action where the mock.js runtime is registered. After that, we add the test input component in which we declare the alert component as we did in the Razor-based test. So I'm cheating a little bit here and skipping the localizer in this example to keep things simple. And finally, in the expected output component, we add the expected markup that we expect to come from the alert component. And again, that is it. When this test runs, it will automatically use the semantic markup differ we talked about earlier to verify that rendered markup from the test input and the expected output are equal. And so let's change gears a little and try something else. Let's now write a test for the dismiss logic in our alert component. So I have the dismiss private dismiss method here from the alert component we can take a look at and go through and understand what we need to test. So first, when the dismiss button is clicked or the dismiss method on the alert component is called, we invoke and await the undismissing event callback. The event args we pass to that allow the callback handler to set a cancel flag that should abort the dismissal, but we're not going to test that in this test, so we're not going to worry about that. Next, the alert component calls and awaits the JavaScript function that returns once the CSS dismiss animation is complete. So this prevents the component from removing its DOM elements before the animation is done. And finally, after updating some state, the undismissed event handler is invoked. So this flow is what we want to test. So the test looks like this. First, we register our JS runtime mock, and then we use the setup method to configure a planned invocation handler for the JavaScript function invocation we are expecting from the alert component. Then we define a dismissing event and dismissed alert variable that should not be null if our event callbacks have been called. With those in place, we can render our alert component and pass in the two event callbacks. Now that we have the alert component, we can use the find method to find the button element, and we trigger the onClick event handler on that. So for our first verification, we find the alert element itself, and then verify that its CSS class does not contain the show CSS class anymore. The show CSS class is what, when it's removed, is what triggers the CSS animation to start. And we also verify that the dismissing event callback has been triggered by checking that the dismissing event variable is not null anymore. So this is the first part of the dismiss flow. Now let's verify the second part. So right now, the alert component is asynchronously awaiting for the JS runtime invocation to complete. Since we configured the planned invocation in the arrange step of the test above, we can now provide a result to it, which will cause the JS invocation to return and the alert component to continue its work. We do this with the help of the wait for next render method on the test context. This method will execute the action we provide to it and wait for the next render to occur. This ensures that the alert component has completed the last part of the dismiss step and has re-rendered before the test continues. This allows us to actually verify the new markup is as we expect. So now for our last verification, which is to verify that the alert component rendered no markup and the undismissed event callback was triggered. So that's the full test. Do note that the verification interaction steps here would have been the same if this had been a Razor-based test. So the last example I think I have time for today, that shows some of the other verification options available to us. And it is a test of the counter page that comes with a file new Blazor project template. So let me just briefly, I know you've seen it a couple of times today if you've been following the stream, but just to be sure everybody is following along, this is the counter, and when we click the button, the counter increases. So in this test, we want to verify that the counter correctly updates when the button is clicked. So first, we render the counter, simple. Then we find the button and we click it, so nothing too exciting yet. To verify that the counter updates correctly, we use the get changes since first render method. It returns a list of differences, one which we can use the should have single text change method on to verify that there are only one change and that it is a text change, and that the text now matches the string we provided to the method. So this is again an example of using a semantic comparison where we ensure that there's only one change. The alternative, we could have done this. Here we just find the P element and get the text content of that. Then we trim away any white space and use the standard assert methods to verify the counter increased. This will also verify that the text has changed as expected, but it will not verify that there are no other text no other changes in the markup. So now let's see if the counter behaves as expected if we click the button again. So first, we use the save snapshot method on the component runner test. It will save the currently rendered markup from the counter component in the test context or in the component runner test. We can use that later for creating a list of differences. Then we find the button again and click it once more. So note that we actually have to find the button again, since the button returned to us previously has been replaced during the render that was caused by triggering it. So after triggering the button, triggering the onClick event handler again, we can now use the get changes since snapshot method to get a list of differences, this time between the saved snapshot and the current rendered markup. And again, verify that there are only a single text change. So I do realize that I've never actually shown you any of these tests running. So let's jump over to Visual Studio real quick, and I'll just show you that it is indeed working as I promised. So here we have our alert component, and this is the dismiss method we tested earlier, and you can see the whole alert component here. I won't go into details about that. You can find that on the GitHub pages. And here, the alert Razor test. Here we have the test we saw before. It's defined here. And here is the test method. There are also a bunch of other tests you can look at in that test file. Here we have the C# version of the test, and again you can see that's the same markup as we showed on the slide before. And here we have the snapshot test. And the counter test we just saw, it's actually here, and a shorter version where we don't test a second click. And let me see if I can get my zoom to work. That's not it. Nope. Zoom it. Yes, let's see, okay. So, no, I guess not. Here we go. So down here we have our tests. We have our Blazor-based test. We have our snapshot tests, and we have all of our tests. So if we run these, we should hopefully see a number of green dots coming back, and it's building and compiling. I hope I didn't mess anything up with my random clicking. Yes, and here we go. And you can see that all the tests ran as they expected. There are actually a lot of tests in the test solution, so there's a lot of tests to dig into if you want to see examples. Just in the sample app, there are 31 tests, and so that should be a lot of things to look at. Okay, let's get back to the slides. I'll just have to zoom out again. Okay. So there are a lot more I want to talk about, but there are also other great sessions waiting for you, so I'll stop here. Thanks very much for the attention, and we can jump over to some questions now.
Yeah, so Eagle, thank you so much for the presentation. Unfortunately, again, since we have a live speaker, we're going to have to cut questions short.
Sure.
However, we do have questions on Twitter, so if you want to take the time to go answer those, and I encourage everybody out right now watching the stream to keep putting the questions on Twitter. We're getting just a little behind with the sessions back to back that it makes it difficult to answer them. So thank you so much. I have the next speaker here.